Okay, thank you for coming, everyone. I appreciate it. You may have seen us before, Redpanda, at previous meetups at Iceberg Summit. We've been involved with the community for quite a while, for the last year or so. And so it's super cool to come back and talk about a new use case that we found for our Iceberg integration called Iceberg Topics. And it's really interesting to kind of see how quickly the interrupt and the zero copy kind of nature of Iceberg unlock new use cases that compress the time to insight, and it also makes it a lot easier to plug in additional, additional products, additional analytics capabilities like graph analytics that we're going to talk about today with Dan from PuppyGraph, CTO of PuppyGraph. I'm the head of product for the platform team at Redpanda. So I'll go ahead and get started. And this is us, as I already said. Okay, so this is going to be a cybersecurity use case that we're going to talk about. Why cybersecurity use case is difficult, which makes security teams overwhelmed. Back when I was in the big data world, we used to talk about volume, variety, velocity of data. This has got all that. It firehose of lots and lots of different types of event streams that you need to scrape in order to implement cybersecurity analytics at very, very high line rates, very, very high throughputs. You can't just do simple filtering. You can't just look for, interesting accesses that, didn't use MFA, which means it's a machine-to-machine authentication attempt. But what do they do? Was it actually suspicious? A lot of it's normal, but depending upon a lot of things like the context window of time and, where they tried to contact, and then what they tried to access, and the patterns of that, are they sort of looking for vulnerabilities by sort of connecting to every possible endpoint in this topology? Well, that's probably a little suspicious, right? So you need context. You need to understand the relationships between all the entities. You need to understand the underlying, data itself. What is an MFA attempt? You need tight time windows to do these analytics. And these existing solutions are out there, but they're extremely expensive and often can't keep up with the volumes of data that you're ingesting. So take an off-the-shelf solution like Splunk, you start burning through your budget really fast, and you also get multiple copies of the data in these systems. Every single different scene system you have, plus your stream, plus your warehouse pre-Iceberg, that's a lot of copying data around, and it's a problem. And we'd like to avoid that. And so if we wanted to build a stack that avoids a lot of those problems or deals with a lot of those problems in an elegant way, we would have a fast, high throughput, I don't want to lean too far on this side of the room, it's kind of naturally happens, low latency streaming engine like Redpanda. So some of the use cases are true real time, 10 milliseconds, 5 milliseconds. I have a couple customers who are doing 1 or 2 millisecond sort of end-to-end latency. It needs to be high throughput because these are really some of the highest volume streaming applications out there. And of course, it needs to be lower cost per unit, right? Lower cost per gigabyte per second, megabyte per second stream. A scalable open table format is really what would help you avoid you copying that data around. Talk more about how both products enable kind of zero ETL approach, zero copy approach as well. But also allow you to swap out different analytics platforms like PuppyGraph and others for different types of use cases that match the problem that you're trying to solve very easily. And of course, make data just accessible to devs and anybody who's got an Iceberg client. That's why we're all here, right? And then you need relationship-aware querying, which is where PuppyGraph comes in, where the graph model comes in, which Dan will talk about extensively. We've been at this game for a while in cybersecurity, powering some of the biggest cybersecurity applications out there, like Lacework, which is now part of Fortinet, or Akamai. Obviously, they push a lot of data. And these event streams are just that. They're many gigabytes per second. They have relatively tight SLA. It's not the lowest latency things in the world, like hedge funds, high frequency trading, but fairly quick. You need to be able to respond in tens of milliseconds at least. And, it has to be cost effective, obviously, which, package apps just aren't going to cut it in general here. But we've been doing this for several years and servicing these companies. And Iceberg is really what provides the pluggable substrate where you can put different engines on top, right? To a cybersecurity data lake, let's call it, right? Where you run all your cybersecurity data and then you bring to bear all these analytics capabilities atop that data in Iceberg, in your cloud store. Of course, we love Iceberg. Why are we here? Iceberg. So Redpanda is if you haven't heard of Redpanda, probably a lot of you have, but we are really a Kafka-compatible streaming data platform that provides a step function improvement in low latency, in total cost of ownership. So how many brokers do you need to achieve this throughput with this latency, right? Much, much easier to manage than the traditional Kafka stack that has kind of grown a little bit crusty over time, a little bit bulky over time. And also sort of a connectivity suite for building pipelines end to end, whether you're bringing IoT data, cybersecurity data, CDC data from Postgres, sending it back to, okay, we can have Splunk in the picture. I didn't realize that was in the picture. Or your data lake houses or other downstream systems applications, right? Being a typical kind of message broker, message bus, providing that connectivity suite that's also a little bit more lean and mean and modern than the old little crusty Kafka Connect, which is getting a little long in the tooth these days, so according to our customers. So that's what we do. We've been around for 6 years. We have hundreds of customers. We power a lot of the biggest companies in the world. I mentioned hedge funds, banks, software companies that do cybersecurity, gaming companies, manufacturing companies, IoT, and lots of other companies. So we have a very, very efficient architecture, I would say, that really delivers a lot of the value in terms of higher throughput with less infrastructure and fast. Cut out a lot of the fat in our architecture, but provide a very delightful developer experience as well. So if you want to do connectivity, but if you also want to do inline transforms with WebAssembly, we're going to have a really nice web UI, favorite web UI. An ecosystem used to be called Cal. It's Redpanda console now. REST API for Terraform, Ansible, all the automation stuff, Kubernetes. We have all that built in, as well as direct integration with lots of AI frameworks. You can call GPT, run Llama, call Vertex DB, all that. And then you can run anywhere is the other big thing. This is probably covering up the logo. It's AWS, GCP, and Azure, the top 3 clouds. We have fully managed services, both serverless, single tenant, run inside your own VPC, or of course just manage it yourself, but supporting on their object stores in all those 3 clouds. And we're the first really company to be able to have this on all 3 clouds, including the Iceberg integration. There's other vendors out there that might do it on one cloud. We do all of this on all 3 clouds in all the different form factors that you see there. Bring your own cloud being a pretty popular one these days because people want to reuse their own cloud environment, network credits, burn down of their, what they're paying to the cloud provider based on open standards. Okay, enough about Redpanda. Iceberg topics. We presented this at Iceberg Summit as well. It keeps improving and the ecosystem keeps evolving as well. So what it is really uniting streams and tables as one entity, one lifecycle, one storage platform to support both stream queries, basically Kafka API based, or at this point of work, using our suite of connectors, right? So you get your IoT data, or your cybersecurity data coming in through connectors, through the Kafka API directly, drop-in replacement for any of those applications, right? Speak the Kafka protocol, and then data comes in into a log format, and your consumers can go and read it. And then your Iceberg clients can also go and read it, which is the Iceberg topic piece, right? So you just flip a switch, like I'll show you, and it'll be on, and there's this big ecosystem of Iceberg supporting vendors and frameworks. You guys know that already, Flink, Spark. There's PuppyGraph in there, right? And many, many others. And then we also integrate directly with the Iceberg catalog, so we push over Iceberg REST. Jason talked a lot about that today. The new lingua franca for interacting with Iceberg tables. So we have customers using, Databricks Unity or Snowflake Open Catalog or Polaris or Nessie or AWS Glue, all of these things. Just talked to an engineer today. We're just wrapping up our integration for AWS Glue. We've used Tabular in the past. So basically, we commit data into these tables for you. We create the tables. We remove the tables if you want to delete the topic. We handle all of things like partitioning and dead letter queues and other things I'll talk about as well. So the really cool thing here is, yes, your cybersecurity data can be unstructured. It can be raw logs. It can be textual data. That's fine. We can deal with that. We can throw that into a semi-structured Iceberg table with just a key and a value. But if you have structured data, you have events that are coming in to your security context that have some sort of schema, protobuf, avro, JSON. We can land that data really in an SQL or graph-ready format with one pass, right? So we take that data in, We know what the schema is. We schematize it. We have less than a minute lag of the data coming in, being produced to the Kafka topic, to landing queryable in the Iceberg table. You can even go more aggressive and get it there in 10, 20 seconds if you want to, right? You got to get with the small files, and you got to get them compacted. You guys all know this stuff, right? But it's partitioned, right? It is clean because we filtered out all the bad data into a dead letter queue automatically for you, right? It has the schema, it has the types, including hierarchy, right? You can evolve the schema if the events change without writing any code, without breaking the table. Thank you, Iceberg, for doing a good job with schema evolution. Thank you all those folks that were there. So you need to add a column, remove a column, reorder columns, widen precision of something, anything that's supported by the Iceberg spec for schema evolution, we can do it. We bucketize data using Iceberg bucket transforms automatically, right? And then PuppyGraph, right? We can feed its graph view of the data in near real time also, because the data doesn't have to move by querying Iceberg data in place. Think about traditional graph databases, right? So traditional streaming, you copy your data with a Flinker Spark job over into your data warehouse table, right? Or your data lakehouse table, right? We don't have to do that. It's automatically there. Then if you have a graph problem, you suck the data out of wherever that is and you put it into a graph database, right? Make another copy of the data. And then you can express things across data graphs. So that's 2 extra moves, 2 extra copies of the data, 2 extra, there's costs associated with that as well. So it's a little fuzzy on this screen. I think on that one, maybe it's a little better, but here's like a protobuf. It's a little different use case, but I just wanted to show that you can, express your schema, use the existing schema you have, JSON over a protobuf, and then you just go in here, and sorry, this one's a little fuzzy. You just basically set a topic property. It's just conf, right? It's conf on your streams with the normal Kafka topic properties, using any Kafka client that you want. You just set these 2 things. Where's my schema? It's this protobuf. It's in the schema registry here. Go and get it. Get the latest version. We'll pull out the latest version from the header, and we'll identify it. And then what's my partition spec? So if you do Spark partition by, right, you have multiple partition keys, year, month, day, or if you don't have, hour, then you can bucketize timestamps by hour. It does that automatically for you if you don't tell it to do anything. And then you can also add additional elements. So you can say, like, what type of event was this, right? What factory did this come from? Any other column in your data can be used as another partition key. With Iceberg, you can always repartition data without recreating the table, which is awesome. But here it just makes it really just as simple as a single configuration property to get this data into analytics ready, SQL ready, or graph ready format with a single pass over the data. All right. I think with that, I'm going to hand over to Jack.
Thank you. Thank you, Matt. So, yeah. Thank you. The PuppyGraph, right? So, just to recap, PuppyGraph is like graph query engine, not a graph database, and it's capable of querying Iceberg data. It's kind of like, native support for open source learning, like the popular graph query languages they can use with, databases as well, graph databases as well. But it is querying on top of like Iceberg as well as other data sources. Then you're going to have the single copy of data, but you don't have to replicate that in a different database. So before we say, we're going to show some demo very soon, like how we're going to use like Redpanda, Iceberg, and put together, do some security analytics. We want to maybe check why graph for security analytics. So as we observe, right, like when we get the logs, right, they are events, and like actual discovery, like we found is like they're not just flat logs, right? They are actually linked entities. They're linked stories. So, for example, AWS, like Cloud Trail, like logs, contain a lot of things like assets, vulnerabilities, like or like hardware, like gateway, as well as like identities, like virtual items. These things are actually naturally connected to each other. And if we parse the logs and directly consume the logs, it's just like entries. But if we view that as a graph, they're actually interconnected. So that's why graph queries and like graph query engines like PuppyGraph provides additional value on top of the same copy of data by providing relationships, like querying on top of these relationships between different entities that naturally exists in a like network, in a system. But this looks great, but the real-time graphs is always hard, like on near real-time graphs, especially like for several reasons. But one thing, as Matt mentioned, right, a traditional workflow will be like either real-time or near real-time stream to some, I would say, analytical warehouse. And if you want to add a graph like feature on top of that, we will have to do another run the ETL warehouse to graph database. Or we directly stream something to graph database. But again, right, graph database is not perfect for like all kind of queries. It's great for query, relationships, interconnected like complex queries, complex like data types. You still need a like relational warehouse so that you're gonna do writes or something like that, and you need to make sure they are synchronized, right? You have to do the stream to warehouse as well as graph database. So as a result, you have multiple copies of data, right? You have a list of ETL pipelines you have to manage. You have to make sure they're in sync, data like not out of sync, and that leads to higher complexity and ends up with like higher cost. So what we actually propose here is like a structure that actually with Iceberg centralized and no ETL, right? Redpanda directly manages the Iceberg topics. So any like streams that stream into Redpanda will be actually directly queryable as Iceberg tables. On the other side, PubGraph directly queries Iceberg tables managed by Redpanda's Iceberg topic without requiring a separate copy of data. So this flow, starting from Redpanda to Iceberg to PubGraph, and then PubGraph models graph, users will get direct security insights as the logs flow into, and they'll be actually able to use the graph queries to actually get these kind of insights. So let's do a live demo, and we have the reference actually here. The live demo I'm going to do is running on a Docker. So we have everything running on my laptop. I'm trying to do that on live, and if for some reason it doesn't work, we still have like a recorded version like I did last night. So first, right, we set up this environment. Notice like we actually start Iceberg, basically a foundation of like Iceberg different like, components. We have data stored on like Meetup, and there's like client. And the catalog we use like Iceberg REST. And we also set up like Spark Iceberg because like we want to, in case like we want to just inspect the result. We're gonna not use that today, but just like set like community tools. Besides that, we have Redpanda running in a container and a Docker container running. So we've already have some of the. So this is like a Redpanda. I already have the container started. So I have the Redpanda like box. So I have like that printed out, and I'll start ingesting some data. For sake of time, I already pre-created like the aspect topics using the command you can see, and then it's actually ingest data. We can actually see these kind of data were flowing into, and we see the logs, right? Like Redpanda is actually managing its aspect topics, so you can see the files actually like written into a pocket, and they actually will be registered into the Iceberg metastore or like the REST catalog. So while it is like working, let's take a look at the like PubGraph's interface. So let me try to. Okay, so this is like the UI of PubGraph, and we'll just use like some predefined schema that I prepared last night with we're gonna go through the content of the schema very soon. The idea is like PubGraph directly connects to Iceberg tables, and by uploading this schema, and PubGraph will be able to first know the connection, like for example, the endpoints of the Iceberg, like REST catalog, like a storage, as well as knowing the mapping, because we created like Iceberg topics. They are actually like Iceberg tables that can be used as Iceberg tables. PubGraph needs to understand how to map those tables into like graph components, like relationships, like nodes. So this is like a very quick view of the iceberg. Like this part is like the iceberg connection information Palo uses, and remember the graph information. Like you can see this like just like mapping the tables inside iceberg, and Palo is directly consuming the data from the iceberg without replicating that. So let's take a look at the data as data are flowing into. We see that this is like the first batch of data contains around like 100K. So we can do a case study. This is like just like the, I would say, high level view of the graph. And we have this kind of dashboard. Each of the tile here is powered by a query, graph query. So we're gonna do the same thing in the query part. Yeah, let me clear the history and I have some queries prepared. So we're gonna just go through a scenario where we want to actually, we want to actually just do some query. So let's take a look at the, schema first, right? The schema is talking about a use case scenario where we have some logs extracted from AWS, like cloud resourcing, and there's like a nodes for AWS account, and the AWS account has associated like identities, and identities actually have like sessions in session. Basically, one identity can have like multiple actions accessing this resource. Like each of the access here is kind of recorded as like a event, and we actually group like different events into sessions. So this is like a kind of like simplified version of actually what is happening, and we can always enhance this graph by adding more topics to it in like real production use cases. Let's just do some query here. So I'm going to use Cypher, and Pepper supports both like running and Cypher. Yeah, so we're first just check this first query. It's like two hop, right? Jumping from account to identity and to session, like it's like two hop and basically jump twice. Finding out a pattern where we want to see, oh, we have that dedicated account. We want to see how many sessions like, or how many different like kind of like sessions that this account have. So this number is large. We probably don't want to explore all of them. But we notice like on the session, right? We can also check the schema here. On the data side, there are like some suspicious events because some of these sessions doesn't have the multi-factor authentication open. So basically it's like enabled. As a result, we feel like these kind of things are more suspicious. Let me copy the second one. So we run it and we see the, okay, so this account has like lots of events without MFA, right? And we want to actually look into that further. Let's run this. So we want to actually see the actual queries, actual like events. So here we actually move beyond like another hop, right? We do the account to identity to session. Now we actually move forward one step further on the event. So it's like hop query. And we want to see how many different, how many different results are there event without MFA. We see, oh, there's a large number of that. And we say, oh, we probably want to just return paths. Maybe there are like over 20K, and we want to actually limit to maybe 200, right? We want to do some like investigation here. So it returns like 200 different packets randomly, but we can see there's a visualization here. This is like accounts, and we see, notice like these are identities, and they connect to different sessions, and different sessions connect to events. And we can look into the data further because it's just like describing the structure, right? The visualization. We can click on this, and it's showing up the actual result. For example, user agents, like more information. On the left side, there's like actual like queries powering the interaction on the dashboard as well. And in the end, let's say if you want to do something further, because we categorize some of the actions like very suspicious actions to a certain type of resources. So another step further, that could have fewer information, but more specific. So in this case, let me copy this. Clear the canvas. So let's do on further. This is cipher. Okay, must have return. Did I? Oh, okay. I forgot to do the return path. Okay. Let's. Yeah. So this one returns like redefining results, and we notice that okay, this is like having suspicious access to certain type of resources. Let's take a look at what kind of resources there are. But this one is actually like flow slots, like F3 bucket, and this one could be something different. It's like different F3 bucket. So we'll actually like this just like for sake of time, right? It's just like beginning of the investigation, and we'll always be able to use this kind of data to investigate further and run more queries and get a result back. So yeah, in the end, this is like live demo, so I just want to show one more thing. Right, we talked about making sure it is like data stream, and just send another batch of data and see how like basically after a certain time, the result will be refreshed, and we see like this is like log producing data, and let's check the Redpanda, and we notice Redpanda logs. We notice that like more data being written, and we can actually refresh the dashboard in real time because like remember we have something talking about sizes. So right now it doesn't change because like data is still flowing, but after like let's say like within like several like I would say like 10 seconds or like within a minute, some minute like later you like see like data being written to the Iceberg.
You can configure how fast it's fitting.
Exactly. Yes. Yeah. Right now we can commit like at like 5 seconds or five down, but of course we always tune that. And one important thing is like Redpanda also provides customized config for partitioning, and partitioning is actually super critical for large scale Iceberg tables, right? It's like you want to actually partition data in a way that is actually suited for different type of queries. So yeah, if we refresh it, we're going to see the data increasing, and later it'll actually going to like maybe like 20K and 200K in variance. So yeah, we can go back to the summarizing everything that we discussed today. We have more use case examples following the same pattern where like Redpanda, Iceberg, Happy Graph can actually work on like cybersecurity. We discussed some of the use cases. It also applies to like flow fund analysis and it's fraud in bank and capital markets, as well as like logs events with the context, right? If we want to do some machine analysis. Yeah. So the same topic we actually had a joint tutorial blog published on Redpanda's live blog, and feel free to scan it to read the blog, read the integration, and download it to play it. Yeah, I think that's it, and thank you. And any questions?
Thank you for the talk. I have some questions. Maybe I missed something. Seems to me for the real-time detection, security, or whatever use cases you just mentioned, you need to keep the latency very low, right? Maybe second level, even first level. But you're adding Iceberg there, which adds to latency to the middle level. So I don't see the point of having Iceberg in the middle. Another follow-up question is why not just directly stream the data from Redpanda or Kafka into your graph database, and then you monitor some pattern using your graph, right? And the result those if anything happens.
Yeah, I can start with that. Yeah, so when you ingest data into Redpanda, it's accessible through the Kafka API, traditional Kafka API, in milliseconds. In addition to being put into Iceberg every 10 seconds, 30 seconds, 1 minute, right? So you're right. The real-time use cases, most likely you would have a Flink job or you would have some custom application with a Kafka client in it, reacting immediately, and with a whatever the algorithm is, right, hard-coded to take some action to shut down connectivity for whatever it means. This use case is definitely more for like human-driven exploration. I mean, the visual part of it, at least, right? But the beauty of having it in Iceberg is that you can go and do the deeper dive investigation. You block some intrusions automatically with the real-time application by consuming from that topic. But then humans can go and do follow-up analysis, which is really easy to do with Graph, right? But also, that data in general is accessible to all kinds of consumers that support Iceberg, to your Databricks, Snowflake, like whatever it is, right? Iceberg, right, for ad hoc analysis. So again, without copying the data, right, you can actually achieve both because the copy consumer can react to the data in real time and everyone else can get it from the Iceberg table within, let's say, 1 minute.
Sure, a fair point. But my question is actually, can we directly stream the data from Redpanda into the Graph database?
Can you consume from a Kafka topic directly?
Maybe using Flink or you have a built-in connector directly to that.
We're looking to some of it. Yeah, we're looking at some of the possibilities. Not supported yet, but that's on our roadmap.
Other questions?
Yeah. So my question is on the Redpanda side about how the data is being either committed, because I saw some transformation to Parquet. So that kind of tells me that the data is no longer living on the partition itself of Redpanda, right? So there's some data duplication, because my assumption is that if the Iceberg translation happens to be reading straight from the Redpanda topic, let's say we have a key that lives on a Redpanda partition, wouldn't that create a hotspot, right? That would be my concern, that if I'm querying very aggressively on a particular key that lives in a single partition, I guess if I have 3 replicas, that would create pretty much a very strong hotspot on my Redpanda infrastructure, right?
Yeah, so there's a whole bunch of different aspects to that question. First of all, when data comes into a given topic in Redpanda, we spread around the partitions around the cluster in a topic-aware fashion. So we basically allocate partitions to CPU cores and also to all the individual nodes. Obviously, you have extra replicas for redundancy on different nodes, but we also spread all the partitions of a given topic and the leaders, particularly of those partitions, across CPU cores and nodes equally to try to avoid hotspots. And it's still possible to have like sort of a hotspot, but we can, automatically kind of rebalance the allocation of partitions to cores over time as things change in the cluster to kind of keep the load balanced. It's not a hotspot per key, but you can have a hotspot for very, very large partitions, right? But we're constantly auto balancing that, try to keep it balanced as possible. When you ask about writing the data into Parquet, right? How is it really in the partition? Well, in fact, even without Iceberg, the partition itself is not just stored on local disk. In the cloud, we're always storing it in object storage. So the local disk is kind of just a cache, but like the older data will already be rolled off into S3, Azure Blob Storage, GCS. And the Parquet files are just another set of files with a columnar compressed orientation, right? In that same environment. So it's asynchronously so it doesn't affect the latency, pushed into Parquet with the frequency, the commit interval that you want. So you basically set a target lag. By default, it's 1 minute. And we're capturing all the data from all the partitions and we're writing it in chunks in bulk to Parquet and then doing the commit into the Iceberg table every minute. And if for some reason your cluster is completely overloaded because it's way undersized, we'll give back pressure to the Kafka clients so they can't produce data as fast, so that the lag is sort of always maintained.
So this means that, let's say, Presto tried to query the Iceberg tables that Redpanda is producing, but that means that Presto, I guess, some part of that will only be coming from Redpanda and the rest will be coming from object storage?
No, so Redpanda is pushing these Iceberg tables into object storage, and if Presto is reading, it's always coming from object storage. But you can also have, to the other gentleman's question, a Kafka client, a Kafka consumer, which is reading directly from the Redpanda cluster, and they would be accessing the Kafka brokers through the Kafka protocol, and it may also need to recall some data from object storage, but that data will be in sort of log structured format.
So one last question, sorry to ask me. So, but let's say in my Redpanda have a retention policy on this topic for 14 days, but object storage is limitless, right? So what will happen to the data after it's been expiring on the Redpanda side?
You can actually have a separate retention policy for the table view of the data that can be much, much longer, like months and years in your lakehouse environment. And then your catalog, for example, like Unity, Snowflake, or whatever, right, can do like retention policies, maintenance, add stats, like basically do additional background operations to improve the quality of that data in the table.
Thank you.
I know there's a lot of questions, but we're a little bit over time, though. So if you have any, please,
One more? No, zero.
2 minutes over, but yeah.
Okay.
Thank you.